Welcome back, students. In this class we continue area related to circles, chapter 5, exercise 5.3. So in this class we study the 15th problem. 15th problem. The problem given is, in the figure, ABC is a quadrant of circle of radius 14 centimeters and a semicircle is drawn with BC as diameter. Find the area of the shaded region. So this is a quadrant here. ABC is a quadrant and a semicircle is drawn here, and BC is the diameter. So we have to find out the area of this shaded region. So next is, so the first part here is, we have to consider the triangle ABC. So take this triangle ABC first. So now we'll divide this into, this will take part 1, 2 and this as 3. We divide this given figure into 3 parts. So we'll take the first part, that is, this is part 1. So part 1 we are considering this triangle. So here take the triangle BC square. We can write this one as BC square is equal to, that is, AC square plus or AB square plus AC square. Now we have this one as, that is, radius as 14 centimeters, then this one as 14, this side as 14 centimeters, this side as 14 centimeters. Therefore we will substitute here. AB is 14 centimeters plus BC is equal to, so we don't know the diameter, so therefore this is also 14 square. So now we'll simplify this, add these two inside the bracket, means this becomes 2 times 14. So 2 times 14, 2 square and also whole square. So therefore this can be written as 2 into 14. So this is not required. So now after this, 14 means this 2 excuse me, this 2, this square root cancels, then this root 2 is left. So I show this, this will be like this, root 2 into root 2 14 square. So this I have split this into 2. Therefore root 2 is there, that is 2 times 14, then the 14 whole square. So we will write like this, we can write like this, that is root 2 into root 14 square. This 2 with root cancels here, since we have single 2, therefore this can be written as, this square bracket is cancelled, therefore 14 root 2 centimeters is BC. So after this, next part we have to take, that is part I take 2, that is part 2. Here we have area of segment ABC minus area of triangle ABC. So part 2, what is this? This one is area of this full segment ABC and area of the triangle, this one ABC. So what is the area of the segment formula? That is theta by 360 into pi r square minus area is half into base into height, that is half into AB into AC. Substitute the values. Theta is what? Here 90 degrees. So 90 degrees Substitute theta by 90, 360 into pi. What is r? R here is 14, radius is 14 square minus half into 14 into 14. Substitute this, 9 ones are 9 fours are, we get 1 by 4 into pi. Pi is 22 by 7 into 14 into 14, 196 minus of into, that is 2 ones are 2 sevens are. Therefore 7 into 14 will become 98. So simplify this, we get 56 square centimeters. So after this we move on to the next part. So I've drawn the figure here. So next part is area of the shaded region. So this is 1, 2, 3. This is 90 degrees. This is 14 centimeters each. So next is area of the shaded region. Area of the shaded region. For this will become our part 3. So part 3 is equal to what? That is area of the semicircle. This one is the area of the semicircle minus this one, that is area of the triangle. So area first minus this one is area of the triangle will become how much? Minus, so that is minus 56. That is, so we'll substitute the values, that is half into pi r square minus 56. Therefore we'll substitute the values here. Therefore half into pi is 22 by 7 into what is this? R square will become 14 root 2 to the whole square minus 56. Now we'll substitute the values. So this is what? This is part 2. The answer which we got from part 2 is equal to this 56. That is area of the segment. Here area of the segment ABC, minus area of the triangle ABC. This is 56 here. Therefore this is part 2. Part 2 we have substituted here, that is area of semicircle minus part 2. Part 2 what we got the value is 56 square centimeters. We'll substitute here. So this minus this, now semicircle we are substituting the values. After this we have to simplify this. So now simplifying this, we have half into 22 by 7, this one 2 cancels here, then 14 square will be, this will be like this, 14 square into how much, that is 2 by 4 minus 56. So this is 2 ones are 2 11s are 11 by 7 into 14 into 14 into 2 by 4, that is 2 ones are 2 2s are 2 ones are 2 sevens are 7 cancels minus 56. Further simplify, we will get this one will be 154 minus 56 is equal to 98 square centimeters. So this is the solution for this. So area of this semicircle minus this. So we have found out this area of this semicircle. So diameter we got, we substitute the values and found out the diameter. Then this minus this is equal to shaded region. Means this triangle and this quadrant and triangle minus this semicircle is equal to area of the shaded region. So this is. So once again we'll see what we did in the part 1. Part 1 we calculated this. We took this triangle ABC and we found out BC here. Substituted the values is given as AC and AB as 14, 14, and this is a right angle triangle. So theta will be 90 degrees. So we got 14 root 2 as this BC. This is part 1. Part 2 we calculated that area of the segment ABC minus area of the triangle ABC. Therefore we substitute area of the segment is theta by 360 into pi r square and area of the triangle is half into base into height. Substituted the values, we got 56 square centimeters. After this, the third part of the answer or the solution is area of the semicircle, this one, area of the semicircle minus these two, what we calculated, that is area of the segment ABC minus area of the triangle ABC. This is 56. Then area of the semicircle is half into pi r square minus this, that is part 2, see, which is equal to part 3. So we substituted the values here and we got as 98 square centimeters. So this thing all minus this area of the semicircle is equal to area of the shaded region. So answer we got is 98 square centimeters. So this completes the 15th problem. We move on to the 16th one. So 16th is calculate the area of the designed region in the figure common between the two quadrants of a circle 8 centimeters each. So a square is there or a quadrant. See, this is one quadrant and this one is another quadrant. All the sides are, this is a square and all the squares are 8 centimeters. So the region in the center is shaded. So you can refer the textbook. I have not written in detail the diagram. So this is a shaded region. So I will just write down this roughly. So you can refer the. So now the first part is, so here also we can write it as part 1. Area of the square we will take first. Area of the square we will calculate first. Area of the square ABCD is equal to what? A square or side square, or this is equal to side square. What is side square? Side says it's a square. We take 8 centimeters the square. 8 they have given. That is, this will become 64 centimeters square. After this, the second part, that is part 2. Part 2. That is sum of, there are two quadrants, that is so we will just write down part 2. We'll consider the quadrants. Consider the quadrants. Therefore, so we'll find out the area of the segment here. This is, we'll take this as A, B, C, D. Considering the quadrant, we'll write one more line. Area of the segment with center D, this one center D and radius 8 centimeters. Radius 8 centimeters. So we'll take the formula, that is theta by 360 into pi r square is equal to, what is here, 90 degrees theta, then pi is 22 by 7 into r is what, 8 square. Therefore simplify this, we'll get 352 by 7 square centimeters. Simplify this. Taking this as a right angle triangle, theta will be 90 degrees. So considering this segment with what means the center as D and radius as 8 centimeters. This is the second part of the solution. So we have this formula, that is theta by 360 into pi r square. Substitute the values. Theta is 90, pi and radius is 8 centimeters. So we will get this 352 by 7 square centimeters. So this is the second part we finished. First and second part. So next part is area of the square will. So next part is part 3. Will take part 3. So what is part 3? Area of square. Area of square. This is A, B, C, D. Area of the square A, B, C, D minus I'll give the number here. So part 1 is okay, that is area of the square. So we'll write it as this one as part 2 and 3. This is 2 and 3. So here we finish part 2. We will consider part 3 as this one. So now after this, area of the square minus sum of area of part, that is 2, you don't get right, part 2 and part 3 and 3. So sum of area of part 2 and 3. So what is the area of the square we found out in the part 1, or we can write it as part 1. So 3 parts we divided the problem. First part we found out the area of the square. Next part is sum of the area of part 2 and 3 we found out. Next is we'll substitute the values. We got 64 centimeters square minus this one, sum of part 2 and 3 is 352 by 7 centimeters square. So simplify this, means we have cross multiply, then we'll get it as 96.7 centimeters square. So this is part 3. Then the last part is, now we have to find out area of the shaded region of the shaded region. So now we have this one, that is 352 by 7, that is part 2 minus this one, part 3. Part 2 minus part 3. This one minus the previous one, minus 2. Sorry, this one is how much? 96 by 7. 352 by 7, this one, then this is 96. Here this is part 3, then this is part 2, will be the area of the shaded region. So to 352 by 7 minus 96 by 7. Finally we get 256 by 7 centimeters square. This is the solution. So part 1 what we did, we found out the 3 parts we have divided. This is part 1, part 2. Therefore first part we found out the area of the square. Then second part we considered the quadrants with the center D, and we have the formula theta by 360 into pi r square. We substituted the value. This is what part 2. Therefore next is part 3 will be area of the square ABCD minus sum of the part 2 and 3. So part 2 and 3. So this is, next is substitute the values, that is area of the square ABCD minus the previous, that is sum of part 2 and 3 is 252 by 7. Finally, so here no need, we have, I'll just take this part 3 because it is confusing. Here only this is the sum of quadrants part 1 and 2. So this, okay, next is, so area of the shaded region is the part 2, this one we'll just take it as, this is part 3, or we can also take it as part 4 only. We'll take this one as part 4, I'll write. So sum of part 3, then here this will be part 4. So don't get confused, it is very clear. So I just wrote this one as part 3 because this is the, here in the figure I have written it as 2 and 3. This we gave part 1. Simply for calculation I am dividing these into parts, that's all. Part 1, this is the combined area of this. So part 2 is the combining of 2 and 3. So after this we'll take it as 4. Therefore this is part 1, this is part 2 and 3. Substitute the values. Finally area of the shaded region is part 2 minus part 4. So now the confusion is clear. So substitute the values, we are getting 256 by 7 centimeters square. This completes this chapter, area related to circles, complete 16 problems. So if you have any doubt, comment me, subscribe my channel, share and like all the videos. Thank you.